Hello there and welcome to Forces 2, Part 2. I recognize I made a mistake on one of my previous videos where I said that this was Forces 2, Part 1. I think it was for Lesson 7, so apologies for that. But today we are looking at Lesson 8, which is on something called stopping distance. This is actually a fairly easy one, and there's not a lot of notes, or I guess not a huge ton of science behind this in terms of physics, but I'll be trying to put it in wherever I can. But it'll feel more like a discussion than anything else. Okay? So what I'd like you to do is get started on the do now. 8 questions. These are actually very similar to the ones in the previous lesson. And this is just because we want you to memorize a lot of these formulas that are very, very important for you. All right, so go ahead and pause the video and we'll get started here. Okay, so there's your answers. Again, like I said, you just need to know a lot of these formulas because these are the things that you have learned over the years, and the reason why we're having you memorize them is because they are not given to you on a physics equation sheet. So you need to be able to recall all of these equations. Okay, so looking at stopping distance, we're looking at two major things, which is thinking distance and braking distance. So these two overview points are actually quite simple to understand, and you, as a common human being, probably know a lot about cars, especially in year 11 right now. So you're gonna find most of this actually very, very easy to understand, or at least I hope so. So let's start off with the stopping distance part of it, okay? If a driver of a vehicle sees a hazard on the road, so hazard just means something dangerous, something you want to avoid, in front of them, they may have to perform an emergency stop. This is when maximum braking force is used to stop the vehicle in the shortest possible distance to avoid hitting the hazard. So this might look like a child who has run onto the road, or the car in front of you stopped, someone is going in front of you. Any of these could be hazards. So whatever the reason is, you want to stop your car as fast as possible. So there are two main factors which affect stopping distance, and they are thinking distance and braking distance. So thinking distance is the distance the vehicle travels during the driver's reaction time. We're going to look at this a little bit closer, but that's basically what it is. So every person who drives a car has a reaction time, and everyone's reaction time is different, but from the moment that you visually see the hazard to the moment that you step on the brakes, that would be your reaction time, right? And then after you step on the brakes, the car doesn't just stop. The car will still go for quite a while, depending on how fast you're going, and that is what we call our braking distance. So that's the distance the vehicle travels under the braking force. So from the moment that you step on the brakes, however far the car travels until it comes to a complete stop, that's your braking distance. So in essence, everything all together, it's in bold there underneath. I didn't highlight it, but you should. Stopping distance equals thinking distance plus braking distance, which makes sense because if you're thinking about all the factors that go into, how fast can you stop a car, you do have to take into account how fast it takes for you to react to the hazard, and then how far the car actually travels. So, what is the stopping distance of a vehicle equal to? Simply put, it's equal to the distance traveled during the reaction time and the distance under the braking force. So I'll just pause, if you want to pause the video really quick and just make sure that you have that answer to the checkpoint question. Again, like I said, not a lot of annotations right now, but as we get into more of the factors and the science behind those factors, we'll be making a bit more notes there. All right, next in your booklet you have something that looks like this, and these are typical stopping distances at different speeds. So the portions of the bar in blue would be your thinking distance, and then the portions in red is your braking distance. So you can clearly see that the faster you're going, so on the left side we have speeds going from 20, 30, 40, 50, all the way up to 70 miles per hour. And at different speeds, your thinking distance is also increasing, but also your braking distance is increasing quite a bit as well. So just to put this into perspective, if your car is traveling at 40 miles per hour, right? So that's the third one down. Then your car will on average, travel about 12 meters before you actually step on the brakes. And then after you step on the brakes, your car will go for another 24 meters until it comes to a complete stop. Okay, and so that's a total stopping distance of 36 meters, right? Because the equation that you guys just learned was that stopping distance is thinking distance plus braking distance. So 12 plus 24 is 36. And it gives you kind of a general idea of how long 36 meters is, and it's about 9 average cars, right? So it's actually quite a lot. And a lot of this video, or this lesson at least, will feel almost like a PSA about car safety. So if it does feel like that, then that's what it's going to feel like. And I just wanted to show you another graph because obviously this doesn't apply to everyone because everyone has different reaction times. So this is actually just a quick study on how age can affect reaction time. So you notice how the younger you are, the faster your reaction time. Okay, and obviously they didn't want to check anything before 4 because your motor skills are still developing quite rapidly, so your reaction time would actually be quite large. So that data doesn't actually fit. But generally, most people will start driving anywhere in their late teens, so you're looking around the red and the orange bar, right? That's generally when people will start driving on average, and it's quite lower than you think, right? So reaction times on the side there is on average about 0.18 seconds. Okay, so all of this less than a second, very very fast, and that's just because your brain works quite fast. So when you have a visual cue, like a person stepping onto the road, the time that it takes for that cue to hit your brain is very very fast. Now, whether or not you can actually step on the brakes when you see that person is a whole entirely different issue because everyone drives differently. But I just wanted to show you that graph just to show you that reaction times are different depending on your age. But obviously, there are lots of other issues as well. Like if you have any motor issues, meaning if you have any issues with how your body behaves physically, and also your mental state as well on driving. Okay, factors affecting stopping distance. So I'm going to try and put in as much science into this as possible. Obviously, a lot of this you're going to understand just by knowing the dangers about driving and how you need to be cautious. So there factors of affecting stopping distance. I'm just going to put the formula up there to remind you what we're talking about. There are many factors affecting thinking and braking distances. The factor which has the largest effect is the speed of the vehicle. So this is actually really important because the faster you're going, as we saw in the chart in the previous slide, the faster you're going, the longer your distances are going to be, both for thinking and for braking distances. And I'd say the more dangerous one would be your thinking distance because if you think about it, from the moment that you see the visual cue and the moment you step on the brakes, that's your thinking distance. Your car is still traveling at whatever speed you're traveling at. But when you have your braking distance, you're still slowing down, okay? But you're still traveling at quite high speeds if you're going there. So that's the largest effect is the speed of the vehicle, which is a huge reason why you should follow the speed limits of the roads. All right. So whatever the situation is, your speed will affect both thinking and braking distances, as we saw in the chart above. So thinking distances. So we're going to look at thinking distance first. That is dependent on reaction time. And the reaction time is the time taken, or sorry, the time between the driver seeing the hazard and applying the brake. So this is one of those definition things that you need to know. And I've said this over and over again, but this actually puts it into text on what you should be able to identify. So for the same reaction time, the higher the speed that you're traveling at, the greater the distance traveled before the brakes are applied. And simply put, this just basically means that when you're going at a high speed, you're covering a lot more distance because in between that time, right, in your reaction time, your car is still traveling at maximum speed. Okay, so there's nothing slowing your car down during your reaction time, which makes it quite dangerous. And if you're curious about whether or not you have a good reaction time or a bad reaction time, there is a really quick, simple experiment that you can do. It does require two people, so if you find someone that would like to do this with you, then you can go ahead and do that. But you may have done this before in a previous science lesson, maybe when you were in primary. But simply put, you have two people. One person is holding a ruler, and the other person is getting ready to catch the ruler. And what's important here is you want to the person who's catching the ruler, you want your thumb and your index finger, so whatever fingers you use to catch it, you want them to be at 0 of the ruler, and you want to try to keep it as consistent as possible. And what you're going to do is the person holding the ruler is going to drop the ruler, and as soon as it drops, that's your visual cue to grab the ruler as fast as you can. Okay? What's really, really important here for this experiment to work is the person dropping the ruler can't let the other person know when they're dropping the ruler, right? Because that's not fair. And if you want to put this into car terms, you're never going to know when someone is going to step onto the road. Okay, you might anticipate it, but you never really know if someone is going to just jump onto the road. So the reason for not letting the other person know about the ruler drop is just to make sure that the test for reaction time is accurate as possible, because you can't prepare someone, because that would skew the results. Okay. So after the person drops the ruler and you grab it, you measure the distance between where you grab the ruler and the 0 point on the ruler. And from there, you should be able to figure out roughly how good your reaction time is. And you want to make sure that if you want to see if you have a fast reaction time, then the distance or the length that you're catching the ruler at is as small as possible. Okay, so hopefully that makes sense. And if you want to go and try it out, what I would do is, if you're going to do this, is try it multiple times. Don't just do it once and say, oh, I caught it at 2 centimeters. I must have a really good reaction time. So you want to do this multiple times just to make sure that you get an average, and then that will be your most consistent reaction time. Okay, so that was your thinking distance, and now we're looking at braking distance. So braking distance is dependent on something called braking force. That makes sense. And for the same braking force, the higher the speed, the greater the distance the vehicle traveled before stopping. And this has to do with the type of energy that we're looking at when you're driving a car, and that's kinetic energy. So when you're traveling at a high speed, you have lots and lots of kinetic energy. And if you remember the formula for kinetic energy, it's kinetic energy equals 1 over 2 times mv squared. So the two things that are dependent for kinetic energy is the mass and the velocity of the object. So in this case, your mass is going to be quite consistent, because most cars of the same make are generally the same weight, and then the velocity is what changes the amount of kinetic energy. So the faster you are, the more kinetic energy you have. Now, in order for your car to come to a complete stop, you need to get rid of all that kinetic energy, right? So the braking force must dissipate all of the kinetic energy in order to come to a complete stop. And that should make sense, because kinetic energy means that something is moving. Okay, and so I just put a picture on the left there of a car stopping, and there are so many factors that affect how a person can bring a car to a complete stop, and we're going to be looking at that a little bit, bit by bit. The diagram on the right, I actually do want you to copy down, because this is actually quite important, and I'll explain this little by little. So right now in the diagram, this shows you a car that has just applied a braking force. Okay, so the rotation of the wheel, starting at the very top, that basically shows you the direction that the wheel is moving, and in turn that should show you the direction that the car is moving as well. The friction force on the disc, now this part might be a bit confusing. So in a car, if you take apart the wheel, you have something called brake pads, and these are essentially the way that your car will slow your tires down. And it actually works the exact same way. If you ride a bike and you apply the brakes, you'll notice that it has these little pads that clamp onto your wheel, and the car works exactly the same way. So these brake pads will apply a force onto the wheel, trying to slow it down. And then on the bottom there, you have the tire pushing on the road and the road pushing on the tire. So this is directly linked to Newton's third law, saying that if there's a force that the tire is applying on the road, then the road will apply the same force back onto the tire. And we want to stop that, basically. We want to make sure that there's no more force that the tire is applying onto the road so that the car will come to a complete stop. Okay? So these brake pads, the friction force on the disc is actually really important for the car to come to a complete stop. Okay? So let's look at some of the factors that affect thinking distance. So a driver's reaction time can vary from person to person. We know that because if you did that ruler experiment with lots of different people, everyone's going to have different distances. So the typical values range from 0.2 to 0.9 seconds. And so depending on lots of different factors, age, as I mentioned, is one of them, but it's not going to be very accurate because you could have a very, very slow reaction time even if you're 18, 19, 20 years old, and you could have a fast reaction time even if you're 60 and over, right? So, looking at the first factor is tiredness. Okay, so tiredness, obviously, if you're very, very tired, you haven't had much sleep, then your mental state is very, very unstable. So, you might feel that your eyes are heavy, you're very, very sleepy at the wheel, and this is very, very dangerous, which is why if you're driving around in the UK, you'll notice that there's a lot of these rest stops or rest pits, I think they're called, and they're basically little places where you can park your car along the side of the carriageway and just have a little nap there. Okay, so whenever you're driving, just make sure that you are fully awake and you are not tired at all. The second factor is drugs and alcohol, which increase reaction time. Okay, and this should come as no surprise. You should never, never drive under the influence of drugs or alcohol because both of those things will affect how your brain works. And so most drugs and alcohols are inhibitors. And if you're interested in the psychology of things, basically, whenever your brain wants to do something to your muscles, it has to send signals, okay, to your muscles. And when you're under the influence of drugs and alcohol, these are called inhibitors because they inhibit or prevent those signals from being sent. Which is why if you ever see someone who has had drugs or is drunk, their motor skills or their physical aspects will be very, very impaired. So you should never drive under the influence. And there are ways that we can check for this. If you have drugs, the most common one will be redness in the eyes. And if you're under the influence of alcohol, easiest one would be, your breath, because your breath will stink if you're drunk. Also, there are checks that police can do called breathalyzer tests, which is a little machine I have in the picture there that you blow into, and it takes your basically it shows how much how much alcohol is in your blood. I don't know the specific numbers that they're looking for, but there is a number where if it exceeds that number, then you could be arrested and fined for driving under the influence of alcohol. And then the last one is distractions, which would also increase reaction time. So you can easily get fined if the police catch you driving with your phone out and you're looking at your phone, which is why they've introduced more concepts like hands-free calling, I think it's called, where you can connect your phone to the Bluetooth of your car and you just basically talk while you're driving, and you can make calls like that. And this is really, really important. So all three of these things are probably the most common reasons why people get into car accidents, and that's just because when a hazard comes in front of them, their reaction you see in all three of them, reaction time is all increased. And so the note that I want you to write is that reaction time depends on how fast your brain can send a signal to your muscles. So even if you're not under the influence of drugs or alcohol, tiredness can affect your mental state, and distractions also affect your mental state, which means that it takes longer to send those signals if any of these three are affecting you while driving. Okay? So if you ever get into psychology or how biological signals work and how your muscles basically send signals to your brain and back, this is all pertaining to that. Okay? And so these three things are, like I said, the easiest ways to prevent getting into an accident yourself. Obviously, you can't control other people from driving whether drunk or from they're tired or being distracted on the phone, but you can always be proactive in how you drive. The video links that are underneath each of those factors, they're all very, very short. They're all adverts on safe driving. So have a quick look at them and just look through them, and they all go through what you should not do when you're driving. So after looking at factors affecting thinking distance, we want to look at factors affecting braking distance. So this is less of a mental and psychological thing and more of a physical, looking at the more logistics of how the physics works when you're driving a car. Okay, so the first one is adverse road or weather conditions. Icy or wet roads will increase your braking distance. And so a lot of drivers, even experienced people, will ignore this because, if it rains, it actually increases the amount increases the distance of your braking distance. And then the other one is poor conditions of the vehicle. So if you have poor brake conditions and bald tires during wet conditions, this will also increase your braking distance. So the pictures that I've put on there, on the far left is driving in snowy conditions. So obviously that's very, very dangerous. The middle picture is actually pertaining to your brake pads. So I kind of explained this 2 slides before where I had you draw the diagram of the rotation of the wheel with the friction force on disc. So if you take apart the wheel, this is what you will see. And that big chunk of metal that you see on the left side of that disc is your brake pads. Okay, and so looking at that picture, you'll notice that it's very rusty. And when you buy your own car, you want to make sure that your brake pads are in very good working condition, because this is the physical part that will stop the wheels from turning. So you want to make sure that your brake pads are in working condition, and generally you don't have to switch them every often. If you own a car, I'd say I changed my brake pads once, and I had my car for roughly 5 years. And they're not too expensive because they do need to be changed out every so often. More often than you would need to change, say for example, your engine. Okay. And then bald tires. This is actually very, very important. And it makes the smallest difference, but that small difference can, be the deciding factor on whether or not you get in a car accident or not. So the tire on the right is an example of a bald tire, and this means that you don't have any traction on your tires. And you might think, well, it doesn't make that much of a difference, but there's the video that is on there, the one that's 2.5 minutes long, will basically show you how important it is to have tires that have the tread or the traction on them. Okay. Also, it's really important that all 4 of your tires have the same traction, because, say for example, your 2 left tires have good traction and your 2 right tires have no traction at all. When you brake, you'll notice that your car will actually swerve towards the left, I believe. Yeah, that makes sense. Yeah, the left, because your right side of the car will actually travel further because it has no traction. So this is the reason why some cars will actually kind of fishtail, or they'll kind of swerve when they apply their brakes. Even if they don't move their steering wheel, they'll swerve. Okay, so for both of these factors, whether it's bad weather conditions, road conditions, or whether your car is not working properly or the components of it aren't in working condition or good condition, the bottom line is, in both of these factors, it will reduce the amount of friction there is between the tire and the road. And so if you're looking for a very, very good, effective brake, then you want to make sure that you have the maximum amount of friction between the tire and the road. Okay? And as you guys know, the more friction there is, the faster it will stop, or the harder it is to push against it. So you want to make sure that the friction between the tire and the road is as much as possible, so that you have as much control, whether you're braking or whether you're speeding up, right? So yeah, there you go. The last thing I actually wanted to talk about here is actually something that I think all drivers should do when they buy the car, and that's to check your brake lights. So if you've ever driven a car, you may or may not have noticed this, but when you step on the brakes and your car is at a complete stop, the back lights of your car will actually turn on, so the red lights. And then when you take off your foot off the brake pedal, then those lights will turn off. So basically what I'm saying is when you brake, these lights come on the back of your car. And for some cars, it's hard to check because it's not like you're looking at the back of your car, right? When you're driving. And so, you might get pulled over by the police and they might say, "Oh, your brake lights are out." And they may fine you, they might not fine you. It really depends. It's kind of a gray area. But the reason why this is important is if you have someone who is driving behind you and you apply the brakes, but let's just say that your brake lights are out, it actually causes the other driver behind you to react much slower, right? Because there's braking without the lights is less of a visual cue than braking with the lights. So you want as much visual cue as possible to the drivers behind you to show them that you are braking, right? So, like I said, this is feeling a little bit more like a car safety lesson, but you want to make sure that all components of your car are working properly to ensure that you avoid any risk of getting into a car accident. So that is one way to make sure that you don't get other people crashing into the rear end of your car. Okay, so really quickly, we've gone over a couple things. Not too much, I'm hoping, but these checkpoint questions will just make sure that you've gotten all the important bits out of the lesson. Okay, so go ahead and pause the video. 3 simple questions. Go ahead and answer them, and then we'll go over them. All right, so the first checkpoint question asks, for a given braking distance, if the if the vehicle's speed is increased, what can be said about its stopping distance? So simply put, the relationship that if you increase the speed, then the stopping distance will also increase, right? That's the thing that I had you highlight, which was that speed affects both thinking and braking distance. Second one, give 3 factors that which can affect a driver's reaction time. So reaction time has to do with your mental state. So you want to think about things that affect the brain, really. So you have the 3 things, which are tiredness, drugs and alcohol, and distractions. Okay, so these are all things that affect your brain. And then the last one is give 2 factors which may affect your braking distance. And these are going to be things that affect the physical components of your car, and those are bad road conditions and faulty car parts. So any way that you may have described those, that's what you want to write down. Okay, along those lines. Okay, and that concludes the content of the lesson. So I'm hoping that what you guys just learned wasn't too difficult. It's all pretty straightforward, very simple. And we'll move on with the exam style questions. So I believe there's 5 questions, fairly straightforward. Go ahead and pause the video so you can answer the exam style questions, and then we will mark it together. Perfect. I'm hoping that you were able to answer all 5 with ease. The one about the graph may have been a little bit confusing, but that's okay. We'll go over it together. So, number 1, the diagram shows how the thinking distance and the braking distance of a car add together to give the stopping distance of a car. So this is really nice. They actually gave you the formula and the concepts of what stopping distance is, so you don't really need to memorize that, but they might not be so generous on an actual GCSE, so just make sure that you do know that. Use the words from the box to complete the sentences. So you have distance, energy, force, and time. So the sentence starts off by saying the stopping distance is found by adding the distance the car travels during the driver's reaction time and the distance the car travels under the braking force, right? So in this point, you had to just basically understand, well, what is thinking distance and what is braking distance? You had to know the definitions of the two because that's what the sentence was trying to explain. So 1 point for each correct answer there, 1 point for time and 1 point for force, for a total of 2 on that part. Question 2. This is worth 1 point. Which one of the following would not increase the thinking distance? Tick just one box. So the car's driver is being tired, the car tires are badly worn, and the car being driven faster. So this one, very straightforward. you have the first one, which says that the car driver is being tired, and that directly affects your thinking distance. So that one is out. And between the second and the third one, the car being driven faster affects both thinking and braking distances. So, it still applies to thinking distance. The only one that doesn't apply to thinking distance is the car tires being badly worn. That only affects your braking distance. Okay. All right, we come to number 3 and number 4, which have to do with this graph here. So it is really, really important that you guys understand that you can look at a graph and be able to understand what it is telling you. So this graph shows how braking distance of a car changes with the speed of the car. The force applied to the car brakes does not change. So you have speed increasing along your x-axis and then your braking distance increasing along your y-axis. So that line there just basically shows you, if I was traveling at 5 meters per second, then my braking distance will be roughly, I don't know, like 4 meters. And then at 10 meters per second, my braking distance is a little bit more, I think at 10 meters. So basically, it's just saying that the faster you're going, the longer your braking distance is. And that's the answer to number 3. What conclusion about braking distance can be made about the graph? And that is, the faster the car is traveling, the longer the braking distance. So most GCSE questions that have to do with graphs will generally have you try and understand what trend they are looking for. All right, that's the bottom line. And this is an essential skill for science because when you have an experiment, you need to be able to plot your data in a way, or present your data in a way that is easy to understand. So number 4 is an extended question where you need to understand, what would happen if, how would the graph change if I change the conditions? So now it's asking, the graph that you see above is for a car driven on a dry road. Draw a line on the graph to show that what is likely to happen to a braking distance at different speeds if the same car was driven on an icy road. So now your driving conditions have changed, and obviously, as we learned before, if you're driving on bad road conditions, then your braking distance will increase. And what you want to draw is another line that's similar to the one that's already on there, but at the same speeds, you want your braking distances to be much longer. So your line might look like that, okay? As long as it's not crazy, like you're not drawing a line going straight up from 0. It should be still a curve because it is exponential, which just means that it has to be a curve. It should not be linear. Cannot be a straight line, okay? It should be a curve. And the reasoning I gave at the bottom of number 4, where it says longer braking distances even at low speeds, shows you what kind of line you were supposed to draw. Okay, so there you go. Number 3, it's not said there, but you should be awarded 1 point for that, and then 1 point for number 4. And then getting to the last question, you have to read a little bit for this. But it says that a local council has reduced the speed limit from 30 miles per hour to 20 miles per hour on a few roads. The reason for reducing the speed limit was to reduce the number of accidents. Good. A local newspaper reported that a councillor said it will be much safer because drivers can react much faster when driving at 20 miles per hour than when driving at 30 miles per hour. And this statement is wrong. Why? And this was actually a little bit of a head scratcher because you might think, well, yeah, that makes sense. I can react faster if I'm going at different or slower speeds, because if something is slower, then I can react faster. But this is actually fundamentally wrong because if you're traveling at a slower speed, it doesn't really affect your reaction time. Driving at slower speeds affects both thinking and stopping braking distances, right? But your reaction time, whether you're driving at really, really fast speeds or driving at really slow speeds, doesn't change. Your reaction time is constant. Okay? So that just means that no matter what speed you're traveling at, your reaction time doesn't change. Just because you're traveling slower doesn't mean that your reaction time increases. Okay? So the only factors that affect reaction time are directly linked to your driver's mental state. So whether you're tired, whether you're under the influence, whether you're, what was the last one? Distractions, right? Whether you're having distractions. So that one was a bit of a A bit of a tricky one, but if you were able to read between the lines and you're able to figure out, yeah, I'm looking at more of a mental thing rather than, the physical aspects of things. Okay? So there's your 1 point order for that. And please make sure that you have all the correct answers copied down in your booklets or whether you're making notes on this. And that is it. So hopefully, I hope I didn't bore you out with a lot of the car safety stuff. And I know a lot of you are maybe looking forward to driving a car one day. And if you want to avoid getting into accidents and things like that, make sure that you are following the rules. And that way you will reduce the amount of money that you put into your car, right? Because accidents not only cost lives sometimes, but they also cost a lot of money. And that brings us to our knowledge check. 10 questions, again, same thing, just going over what we learned in this class and in previous lessons. So go ahead and pause the video, answer those, just to make sure that you understood everything from this lesson. Okay, here are your answers. There you go. And that is the end of the lesson. So thank you for getting through this video. I'm hoping that this wasn't too difficult for you guys. If had we been doing this in a classroom, I think we would have had a lot more discussion on how cars work, car safety, things like that. But if you have any questions, please direct them towards your teacher, and we'd be more than happy to help you out. Okay. All right. Well, I'll see you in the next lesson. Thank you.